So if we're looking for the limit as t goes to infinity of n of t, we're going to be looking for t to grow without bound. We want t to be as large as possible. We want t to approach infinity. So because the limit, so it says explain the meaning of it, right? Well, the number of fish at time t is modeled by the function. So it doesn't tell us what t is measured in. Whether it's minutes. Oh yeah, the number of fish after 2 years. Okay, so basically what we're saying here is that as the number of years, gets larger and larger, we want to find the limit as t goes to infinity of n of t represents the number of fish in the pond. So as we continue, as time continues to pass, we want to find what the limiting number, the maximum number, if you will, of fish that approaches, right? If it actually approaches a number, right? So in that case, huh?
I said,
So
Sorry.
in that case, which piece do you think we should use?
The second equation?
Well, we want t to be going to infinity. The second part here is from 6 to 8, right?
Okay.
So because t should be as large as possible.
Oh, the third equation.
Right, because t should be as large as possible. And I'm writing this all out on my paper. I'm going to write it and then I'm going to project it on the screen. But because t should be as large as possible, we use the branch of the absolute value function. I mean, not the of the function n of t such that t is greater than or equal to 8, because that's the largest t on there. So therefore, the limit as t approaches infinity of n of t is going to be the limit as t approaches infinity of the last piece, which is 200 plus 80t over 2 plus 0.05 t. Now, have you talked about limits at infinity at all?
Like limits, like as like the limit approaches infinity.
Yeah, have you talked about that?
Yeah, we have.
So if I ask you to evaluate, that limit, how are you going to do it?
Well, it says t approaches infinity, right? So
Right.
it's
It's
coming from the
coming
left
from
side,
both,
right?
it's coming from both directions.
That's what always
Coming
throws me
from
off is infinity. It throws
infinity
me off.
means that it could be coming from left or right. What kind of techniques did she give you for evaluating? It's awfully early to be evaluating limits at infinity in this class. What kind of techniques
She
did
literally just says that like you head in the direction of infinity and that's it.
Okay, but how do you know what the limit is? What has she
Based on the
told?
asymptote.
Okay.
There's like an asymptote. I don't like that's what I've at least gathered.
Well, that's not a bad start. That's not a bad start. That's kind of the intuitive understanding of what a limit is. But what I was asking you is, how do you know what the limit is supposed to be? Does she tell you to plug in numbers? What does she do?
Normally she plugs in numbers.
Okay. So if
Or she like creates a chart.
okay,
I don't know if that makes sense, but sometimes she like
yeah,
makes a chart and it's like the closest number to like 3 and it's like you input 1 point or is it like 2.999 and
right,
then
right, right,
you
right.
input like
Okay, so here's what I'm gonna say. This is not approaching a number. This is approaching infinity. Okay. So
okay.
you have to let t get as large as possible. So what happens? Let me ask you this question. Focus on the denominator here. What happens
Mm-hmm.
when t gets larger?
When t gets larger, the function like expands, right?
Well, the denominator is going to get large, right?
Okay. Uh-huh.
And so you're going to have a large denominator answer. Now, you also have a t in the numerator, right?
Mm-hmm.
So you have to think about what happens here. And I would say that probably your best bet, if you're used to her putting in numbers, would be that now this section, is she allowing you to use your calculator or not?
No, it says no calculators.
Okay, then a chart is probably out of the question for this. And that's kind of unfair to you because that's the only way you know to do this now. There is another way to do it, which you'll learn. I'm gonna pull it up here. I'm gonna actually do this. I didn't write the whole thing out yet because I wanted you to see some of this, but because this is an awful lot of writing. And if you're going to justify this, then you're looking at this limit here. Now, the other way to do a limit like this at infinity, and this may be going beyond your knowledge at this point, but it's certainly not beyond the knowledge of the course, is that you take and you, when you do limits at infinity, you divide every term by the highest power of the variable in the denominator. Okay, now
Mm-hmm.
the other piece of this is, if you think back, now this is a pre-calc skill, okay?
Uh-oh.
This is a pre-calc skill. If this is your function, 200 plus 80t over 2 plus 0.5t, right?
Right.
The horizontal asymptote, which is what you want to look at, where's the horizontal asymptote here? I know where the vertical asymptote would be, but where's the horizontal one?
Isn't it, isn't it like 80 divided by
Yes,
0.05?
right.
Okay.
Yeah.
Oh,
So
okay.
you are correct. Give the lady $100, ladies and gentlemen. So now,
Something right.
if you, well, if you look at, so there's a couple of ways to do this. Since you're not using a calculator here, I'm going to show you, and this is why I wanted to have this out, because I'm going to show you first. So this is your function here. So we have, I'm going to put, let me put the screen up here. So this is, let's see, this is 200. This is going to be, and I'm going to use y equals. And give me a second. I have to, let me grab this really quick because
Yeah, don't worry, Shauna.
I've
It's
been
all good.
waiting for this for a while now.